There we go. So I've got indication that we're recording. So we've been through a quick introduction of some of the folks that will be speaking and presenting this evening. And since we are doing this a tiny bit on the fly, I've got a video to show. Matt, if you could find your video, do you have it stored locally yourself? And you're on mute, so if you would unmute, please.
Yeah, I'm looking for that as we speak, so I should have that in a minute or two.
Okay, so I can go first while you're doing that. Vernice, do you have something to show video-wise or otherwise?
No, I was just hoping that some of the students might be able, our current CFS students might be able to introduce themselves really quickly. So I see Nigel. Nigel, are you there? Would you like to introduce yourself, please? Or Jelani, Timadayo, whoever wants to go first. Jeremy?
I guess I'll go. I'm not home right now, but yeah, my name is Jeremy Amakwa, and I want to become an electrical engineer.
What grade are you, Jeremy?
11th.
Jeremy's an 11th grade student with us. Nigel, go ahead.
Hello. All right, so I'm Nigel. I'm in 11th grade as well, and I want to be a chemical engineer.
Thank you, Nigel. Jelani?
My name is Jelani. I'm in the 10th grade, and I don't know exactly what I want to be, but I think I want to get a computer science degree.
Thank you, Jelani. And Timadayo?
Hello, everyone. I'm Timmy Dial. I'm a junior, and I'm interested in biomedical engineering.
Awesome. And I don't see any other of our current students, but if you're out there, feel free to introduce yourself. Go ahead, Mr. Andrews.
Okay, Timadayo, I had a question for you. Have you done any further work on designing the hovercraft that we were going to build?
I always have certain pictures and videos saved on a Google Drive I have for the hovercraft idea, but I never
Okay, so when we get back to campus, let's jump on that and kind of push that forward. Okay, so guys, what I'm going to do is I'm going to share my screen and run a quick video of one of the units. It describes an overview of the units that we go through in the engineering essentials. So let me go ahead and share my screen. There we go. And then let me pull up the video. So I'll just stand by for just a quick second while I get some things out of the way. And here we go. I did stop that for a quick second. Were you guys able to hear the audio? Okay, so I want to get into, that's fine. I think I know what's going on. I need to go into here and share my computer sound. So that should take care of that. So take two. My name is Mr. Andrews, and I'm going to be talking with you about some of the units that we do in our 9th grade science class, those that are pertaining to some of the simple electronics, as well as some coding that we do with microcontrollers. In this class, we'll start off by talking about electricity, finding what it is so that we have a common basis to start from, a common level of understanding. And then we'll talk about where is electricity used and how do we use it? What is its purpose? What can we do with it? As we move forward in the unit, we'll talk about design of simple circuits, and the students will actually design their own circuits and implement them either in a simulation program and or using the components, breadboards and Arduino boards, which we'll show you in just a moment, in the actual classroom, wire the circuits up and see if what their creations can do. I'm going to go through a demonstration in a tool called Tinkercad, which we'll take some advantage of and I will use. And starting off here, I will show you a couple of circuits that are basically just batteries, wires, and an LED. LED is a light emitting diode. It's the red component on the top of the screen. So I've got 2 batteries on the left, and 2 batteries on the right. But if I start my simulation, you can see that right away I get this little explosion symbol that apparently there was too much electricity for that LED. So it expired, it popped, it blew. We add a component called a resistor, which is this component over here. And that consumes some of the electricity, so there's less of it for the LED. So we can control the amount of electricity by the value that we select. Now you'll see that the LED here on the right, it is lit, it's pretty dim. And currently I've got a value of, I think, 1,000 units. Units are called ohms. So let me back that down to 100, and now you can see that it got much brighter. Okay? So by knowing the circuit equations, we'll be able to calculate the right values to get the LEDs to shine at the desired brightness level. So here we've got 2 LEDs, we have a resistor, we've got some wires, and we have an LED. Let me just move down a little bit in this same screen. And here we've got an Arduino board here on the left. We've got a breadboard, which is this white perforated board on the right-hand side. We've got red wires, black wires, green wires, resistor, and an LED. And currently it's on and about the same level of brightness as we had with the batteries above. The Arduino board on the left is only being used to supply the power, the 5 volts, which I think you can see right here, and the ground, which is like the negative of the battery. So the electricity follows this red wire into the breadboard. And if you can see there's sort of a green faint line, the electricity comes down this row. This red wire goes up. This column then conducts the electricity in through the resistor, through a green wire into the LED, back out the LED, into the black wire, scoots back across, into this black wire, into our ground. We've completed the circuit, and that's what's required to have electricity flow, a completed circuit. So this works. So we'll be working on learning and understanding the fundamentals of how that design works and what we would be doing to make it work perhaps even better, or to whatever specific design and design feature we wanted. I talked about coding. Here's a circuit. It's got the same pieces in it. It's got LEDs, resistors, a bunch of wires, but this time only the ground is hooked up for the power. So when I start the simulation, we'll look at what's going on. You can see that the LEDs progress from left to right. The only thing that could allow that to happen is that each one of the wires, starting with this green wire here on the left, as we progress all the way through these colored wires to the yellow one on the right, they're taking their turns at putting out the voltage that turns on the LEDs. It's the coding that makes that happen, and here's the code for this particular circuit. It's got some setup code up here on top, and then it's got a loop down here on the bottom. So this is the way we introduce and learn about loops. We'll learn about the commands that actually turn on the LEDs, which is this one right here. We'll use the digital write command to turn the voltage high, which will turn it on, and the digital write low command, which turns it back off. We've got some delays in there, and that's how we control this. As we go forward in more complex examples, the students will be invited and have a unit on designing their own creation. And I'm going to bring up one from last year's class, which is a little bit more complex. And this was done by a student whose nickname is Sibo. And his full nickname is Happy Boy Sibo. So what he really wanted to do was make a display of letters that would spell out his name. And I'm going to run this. It's going to be maybe a little difficult to see because we're zoomed out. But as the simulation begins, you'll see that all 5 of those panels light up with the HAPPY. And then the next word is boy. That's the last 3 they turn on. And then SIBO, S-I-B-O, is the first 4. So I'm going to zoom in case we're able to see it a little bit better. It's not easy to zoom in on this particular utility, but let me try. So there we go. That's zoomed in a little bit. And maybe we'll try and isolate the word boy when that comes up. So there it was, B-O-Y. And that would be the B-O and SIBO. It's a little difficult to tell, but if we had this in the classroom and really wired up, you would actually be able to see this quite easily. And that gives a little bit of an indication of the level of complexity and sophistication that they begin to develop. So this was SIBO's own design idea. He did require a little bit of consultation to figure out how to maximize and optimize the number of control wires to the number of LEDs, but he did the lion's share of this work on his own, and he really enjoyed this project. So those are the kinds of things that we'll be exposing the students to. And I think if we're set, that could be the end of this little demonstration. Thank you. Okay, guys, so that kind of takes care of that little video from my perspective. I can see that we had one or two more folks join us. I see Olamide is on the call. I see Rashid is on the call. We had been introducing each one of the current CFS students. So Olamide, if you want to say a quick hello, a couple of words about where you are in school and what you've done here in the STEM department, what classes you've taken.
Hello. Hi, hello. My name's Olamide Balagoon. I'm a junior at CFS from Newark, New Jersey. I've taken like 2 engineering classes at Church Farm School. I'm in calculus right now, and I'm taking chemistry right now as well. Yeah, I've been doing pretty well in all of those classes as well. So yeah, I like STEM.
That's great to hear. Thanks, Olamide. Rashid, are you on? Would you like to say something quickly?
Yeah, I am on.
You've got some feedback.
My name is Rashid Bakri. I am in 9th grade, and I just wanted to see what STEM is like and how it's approached in this school.
There we go. I was on mute there for a quick second. Let me unmute. So thanks, Rashid. Rashid is actually one of my advisees and is in my current 9th grade. So all those units with the Arduinos and the LEDs, those are coming up shortly after you return to campus. So you'll be doing this stuff pretty soon. Mr. Labrador, do you have time and found a copy of your video?
Well, I found a copy, not of the video, so I'm hoping that our fearless leader of STEM will come through at some point. But I did find sort of at least an informal video that describes, it serves as a brief introduction to the robotics program, which historically has been an alternative to sport at Church Farm, in the sense that for students that didn't want to do a particular sport in the season, there's a number of different clubs that they could choose, and robotics has been one of those clubs. And the way I've run robotics is as essentially a sports competition for robots. We've been part of the VEX Robotics program, which is an international contest where essentially each year the designers of the contest come up with a particular sport that the robots do. And we've been participating in that. We're taking robotics in a bit of a lot of a different direction this year, where it's going to be more kind of a mock engineering experience, if you will. But the video I have right now is just a real informal video of the robot that folk that are in robotics this year will have a chance to build. I can give you an overview of what we'll be doing. It's based on a curriculum from a company known as Milestone C, where the first part of it is there is a robot in several pieces in a box that students will build. And it's deliberately designed to build out of the box so as not to work. Because a real experience as an engineer that you'll find is that you'll build stuff and it'll fail. So the robot is designed out of the box to be built and not work. And you get a chance to troubleshoot that robot until it works. And then after that, the processor on the robot is Arduino based, so it accepts code. there will be a phase in the program we'll get to write an app to control the robot via Bluetooth over a cell phone. We'll have a chance to program the robot to have unique functionality using C++. We'll also be doing some work in CAD, whereas we'll have a chance to design new robotics parts. So there'll be a variety of different design challenges that we'll have over the course of what would be a normal sports season in robotics. But what I'll show you right now is just sort of a brief introduction of something that I've done with one of the robots that we'll be working with. So I'm going to try to share that now, and hopefully this will work. Let's see. So there's the robot, and I programmed it to dance.
So Mr. Labrador, I gotta ask you, who dances better, you or the robot?
The robot most definitely dances better than I, because I wasn't programmed for dancing.
So yeah, so if you like robots or if you like dancing, you might consider joining the Robotics Club.
Yeah, so anyway, so there you go. So there's a very brief overview. This is not the video that I had intended to show, but it's sort of, it could serve as a brief overview of some of the stuff that we'll be doing. We haven't done it yet this year, unfortunately, because COVID, but it's my hope that we'll be able to launch, shortly after the semester begins.
Jeff, you're muted if you're trying to talk.
Thank you. I was trying to do that. So when he was going through the video, I did have two questions for you, Mr. Labrador. One was, what was the microcontroller for that robot?
It's Arduino based. I can't tell you much about it beyond that, but it is an Arduino based microcontroller.
Excellent. So then it's going to
Yeah.
use the same sort of programming language that the freshmen will have. So it's a very
Yes.
it's a C-like derivative programming language. That's good.
Yep.
Second question was, the parts that you could design, are those possibly potentially printed out on our 3D printers, or?
Absolutely, yeah.
Okay.
Yeah.
Excellent. Excellent. So you guys can see that we're going to be teaching you skills that you're going to use in various classes. And speaking of various classes, I think Ms. V's got some words of wisdom regarding how you go through and progress through your church farm school experience as a student in STEAM.
Yes, thank you, Mr. Andrews. I'm just going to put up on the screen our current progression through the STEM classes. So you can see, hopefully, that in 9th grade, all students take the Engineering Essentials class, which is what Mr. Andrews was describing at the beginning. And then you have options for 10th through 12th grade for science opportunities. So biology, chemistry, physics, environmental science, intro to CAD and computer science. And we have several of the advanced classes as well, advanced biology, advanced chemistry, and advanced physics right now. This math progression, I am not a math teacher, but here is our current math offerings. So depending on where you come in, for math, as a freshman, you'll be placed in one of these sections and progress from there. And I just have a couple of pictures of some of the projects the students were working on from when I taught freshman STEM class a couple of years ago. I believe Tamado's project is in there somewhere, but just a couple of pictures of some of the projects they were working on. Battery powered cars where the bodies were 3D printed, paper coasters as kind of really quick engineering design challenges, solar powered motors you can see. And then the ones with the fish, those were aquaponics projects from a couple of years ago, where we had students growing, I believe that was wheatgrass, and the fish were hopefully helping the wheatgrass grow. So there's a couple of pictures of student work. For extracurriculars, Mr. Labrador did describe our robotics club. We also have a STEAM club. We did have a neighboring engineering company, which was right behind us in the corporate center, where students could go there after school as kind of a after school opportunity to learn and work with some of the engineers at the, it's called Analytical Graphics. It's an aerospace company. And hopefully that will be able to resume once the COVID is over and that we are able to go places and they're able to welcome visitors again. So those are just some of the opportunities outside of class to get involved in STEM. And these are pictures from some of those things. So the top two pictures were from the AGI practicum. The students worked with the engineers on how to learn how to fly a drone. So they're out in the field behind our school learning how to fly drones. There's a picture of a robot from a couple of years ago with Mr. Labrador. And the bottom picture is a kayak that the STEAM Club built out of saran wrap and PVC pipe. But you can see one of our students was brave enough to get into it and it actually did go somewhere. So that's one of our current seniors, actually. This is from a couple of years ago, but they wanted to do something fun and that's what they chose to do. And then I have one last slide. I'm very, very proud of my CFS graduate. He graduated the class of 2020, so last June. He's now an engineering student at Pitt, and he took all the STEM classes that he could at CFS and is doing very, very well. So he hasn't started school yet. That starts next week for him, but he's looking forward to going back. And he was involved with a lot of things. So you can see he was on track. He was in the band. He's a scout. And at the bottom, there's the class of 2020. So they didn't have a proper end to their school year, but they are doing well. So considering all the things that they had to deal with at the end of their CFS career, they're all doing very well. And I wanted to shout out someone that I don't think we pointed out. So Miss Smoots. We have to shout out Miss Smoots because she got a degree in industrial engineering. Am I right with that?
You are right. My degree is in industrial engineering. And I'm a teacher, kind of, sort of. Yes. But I will say to you, I use principles from industrial engineering each and every day. Each and every day. And I actually got into admissions because of industrial engineering, because my first job in the admission office was to build the office. So set up the policies and procedures. This was a long time ago. So I built the information system that we use. We use FileMaker. Set up, organize the filing system and just, put in all the policies, the processes that I did in aerospace in a school to make things run smoothly. Can't hear you, Mr.
Got it. Yep. Fortunately, Zoom gives you this little sign that says you're muted if you start speaking. I was just going to say at this point, maybe we'll open it up for questions from anybody that we might be able to entertain. Give you just a quick second. And go ahead, Nigel.
No, I wasn't seeing something.
Oh, okay. I just saw the yellow highlight around your name there, so I thought you might have had a question. Any parting words from any of the adults?
Well, I want to try to get some of the students to speak up. So current students, can you answer that question? Olamide, do you see that question in the chat from Julian? Can you still do sports if you are doing robotics or engineering? Are you able to answer that, Olamide?
I think robotics is like a season. It's like a winter season, like afternoon activity. So you can't do another sport in the winter, but in the fall and the spring, you can do a sport.
So yes, robotics is considered an after-school activity for that whole winter season. But so instead of doing a sport in the winter season, you have the opportunity to do it in the fall or in the spring. If you want to do robotics currently, that might change, but currently that is what we have been doing.
I have a question.
Go ahead, Jeremy.
So basically, I'm an aspiring electrical engineer, right? And this or next semester, I have a slot open. So like, what class what class do you recommend that I should put in that slot?
Have you taken the Introduction to CAD course?
No.
That would be something you could think about.
All right.
Because we're going to be going into Fusion 360. Mr. Mazzoli is going to be the lead teacher on that, but I'll be assisting. But you'll be using some Tinkercad design in there, I believe, which I know you're already familiar with because you had that in the past with me in Intro to Engineering. But we're going to be using Fusion 360, which I'm pretty excited about. That's a pretty high-end modeling and design CAD tool, so that'll become nice.
All right. Thank you.
If I could add to that, my major in college was also electrical engineering. One thing that I noticed as a student is that lots of math helped. Like generally, to the extent that you can through Church Farm, I would say take as much math as you can to prepare yourself for college level classes in engineering,
including statistics.
Absolutely.
All right, thank you.
Other questions, gentlemen?
I have a question for some of our students, whoever would like to volunteer the answer. What was your most favorite project that you did in STEM? Because some of you are 10th graders, 11th graders, you've been here a couple years. What's your most favorite experience with STEM at CFS?
I remember freshman year, we had a lot of projects. I remember the first one was the Marble project, which I thought was pretty cool, but one of the most memorable STEM related project in that class would be the, I don't know if I'm saying this right, but the aquaponic. I remember it was in the clip you just showed. It was interesting because I remember a little bit about it, but it was basically the objective, I believe, was to filter the water to ensure that the fish or the guppies or whatever was in the tank that we designed were able to feed off of the pebbles or the pellet. I thought it was really cool. So that's probably one of the STEM projects on the top of my list.
Olamide has a question. If I am looking to become an engineer in the future, should I still take AP Calculus if I am already taking calculus? Mr. Labrador can probably answer that. He teaches, Mr. Labrador teaches our calculus classes right now.
Yeah, I love teaching calculus. To me, it's like the most wondrous math that I've seen, in the sense that some of the discoveries that you can make only through calculus to this day give me a sense of wonder. But in terms of curriculum, I would say if you have already taken calculus, I would not advise taking AP Calculus after having already taken calculus, in the sense that it's not a different subject. And if you'll recall from the slide that Ms. V showed, it's not even called AP Calculus anymore. It's calculus, and then it's advanced calculus. We used to have AP Calculus as well as regular calculus, but it's not a different subject. It's calculus. So the difference when you have the initials AP in front of it is that you may go through one or two extra topics, extra subtopics within calculus, but you're not learning a different subject. So to me, it would feel very, sorry about that. To me, it would feel very redundant. So I wouldn't recommend taking AP on top of it. I think you could probably, after having taken any one of my calculus classes at Church Farm, you'll have enough skills to be able to sort of research on your own, I think, and which is something that I would definitely help anyone with if they so chose. But yeah, I would definitely take one or the other, but I wouldn't take Calc then AP.
So our advanced classes, our advanced science class, science and math classes are not labeled AP any longer, but with a little bit of work, extra work, you would be prepared to take an AP test if you so desire to get credit. So that is an option. It's going to be a little bit of extra work, but just because it doesn't have the advanced placement label in front of our class does not mean that you would not be prepared for an AP test. But the curriculum's not following the AP curriculum exactly. So there is going to be a supplemental work you would have to do if you want to take the AP test. So Nigel has a question. Would you encourage doing calc in the summer and focusing more on sciences like AP Chem for someone going into the chemical engineering field? I'd like to address that one because I currently have a freshman college student in engineering, and he is taking chemistry and physics and calc all at the same time. So my usual recommendation for students who ask is take what you are interested in. If you are interested in chemistry, it's probably a good idea to see if that's really what you want to do by taking the challenging courses in that area. So it just depends on what you really are interested in, because for most engineering programs, you're going to have to take calculus and physics and possibly chemistry anyway. So the more exposure you have to all of that, the better off you will be.
And I guess if I could sort of piggyback off of that thought, so I teach calculus as well as this year what's called advanced physics at Church Farm. The nice thing about that pairing is that one of the architects of calculus was Sir Isaac Newton, who invented this topic of classical mechanics, what we know as in Church Farm as physics. And he primarily invented calculus, really, believe it or not, to make physics easier to understand. So I think there's a kind of a nice dovetail, particularly if you're taking physics and calculus together. To some extent chemistry, but certainly physics and calculus, they go nicely together. The other thing that I would sort of like to mention, sort of going back to well, calculus or AP, and why we don't have AP on the name. As Ms. V stated, if you were to take an advanced science or an advanced math class at Church Farm, you would definitely be equipped to be able to succeed on an AP exam. But I think the virtue of, and it was a conscious decision of Church Farm to take the label AP off of the name, in the sense that it gives us teachers actually the freedom to make it better, in the sense that we're not constrained by some of the restrictions of a strictly AP curriculum. We have the freedom and ability to make those advanced courses a little more expansive, I would say, even.
Other questions, folks?
I guess I have one question. So, freshman year, originally I was interested in mechanical engineering, and then I did research and I found out that like most of the things that I had thought mechanical engineering was probably not exactly what I thought it was. And then of course I'm still interested in it. At the same time, recently, I guess last year, I've been looking more into biomedical engineering, and I was just wondering if it's possible, if anyone knew, since I believe that all of you are all, I guess, STEM, have a good foundation on STEM related curriculum and all that. I was just wondering like what specific guidelines or what specific classes would be something that I should look forward to in biomedical engineering, like specifically like any classes in particular or any extracurriculars I should look forward to getting myself involved in, specifically for biomedical engineering.
So I'll say a quick word or two, and then Ms. V, I think you might have something to offer based on CJ's path. I guess first and foremost, you know, if you're thinking of biomedical in terms of like prosthetic design, things that are engineered to help support the body system, is that kind of where you think you're headed?
I've read a bit about that, and I think it's interesting. But then I saw another one about regenerative medicine, specifically with stem cells and neural cells and all that. And I thought that was interesting as well. But I'm just trying to learn more as much as I can about it.
So if you're thinking of designing devices, mechanical devices, that's where the mechanical engineering comes in, to assist in recovery or recuperation or something that humans, the body actually does and works and accomplishes, then you're definitely going to want to take some of the courses that get into the design work and fabrication, like the introduction to CAD design that I was speaking to earlier, right? Because you're going to have to use sophisticated design tools to create gears or wrenches or different things, and actually execute those to the level of fidelity and detail that they can be successfully printed on a 3D printer. You can't just print anything on a 3D printer. There are certain characteristics and mechanisms or approaches that you need to use. And you'll get into the whole concept of tolerance and why that is so important in those kinds of designs. From the biology side in biomedical engineering, well, that kind of obviously points towards biology, and perhaps Ms. V, you can kind of pick up the story from here.
Yes, thank you. My son is intending on majoring in biomedical engineering, and what we are finding out from conversations with his advisor is that most engineering programs, the first almost 2 years, everybody takes the same coursework, and so it's his own advisor has suggested leave your mind open, because you might find out that you like one area over the other. But if you really, really like biology, then yes, that's the path you're going to follow. But they don't lock you in usually when you take college programs. So I guess my suggestion would just be do the best you can, get the best grades you can, take as much STEM as you can to prepare yourself for that. But then leave your mind open once you get there and take your required classes. They call it first year engineering usually at most colleges, where all engineers take all the same classes anyway. And one of those classes that my son is in is a survey type class where they learn about all the different branches of engineering so that they can get a little bit better idea of what really sparks the interest. So stay with it. I guess that's the advice that I have. It's difficult, but if you are passionate about it, then that means your everyday will be that much more fun if you really like it.
That's kind of good to hear, because back in the dark ages when I was in college, you didn't declare what kind of an engineer you were going to be until your second semester sophomore year. So everybody was taking chemistry, physics, calculus, all freshmen, both semesters. And then in sophomore year, everybody, I think you were done with chemistry at that point, but you were taking physics again and calculus for your third and fourth semesters of those. But yeah, it wasn't until you were a sophomore, second semester sophomore, that you declared whether you were going to be electrical or civil or whichever you were going to be. So I think Ms. V's recommendation is right on target. And they even had a survey class back in those dark ages too, because there was a whole semester where you took an intro to civil, intro to mechanical, intro to electrical, intro to whatever. You got to pick those. And then a programming course. Everybody as a freshman took, it was Fortran back then, a Fortran language programming course. That's the other thing I would recommend that you seek out through your experience here at Church Farm School. Look for the courses where you're going to have the opportunity to develop and write code. because as an engineer, you're almost never going to get away from it, at least at some level.
Nigel's got a question. What would you consider the hardest engineering majors to study? I would say they're all hard.
Wow. Mr. Labrador and I are both electrical engineers, so you know we've got that as a bias. It depends. The engineering is so vast, and with any degree, the different things you can get into. So any one of them can lead to a very challenging and rewarding career, and any one of them is going to have their ultimate test. Like I remember for the chem major, organic chemistry was the class that they had to deal with. Dynamics was sort of the class for the general population of engineers to deal with, because statics was hard enough. Then when you get to dynamics, everything that you just finished doing all your calculus with curls and all those calculations, now it's all moving. So that was a tremendously hard class. But they're all
I
going to be
remember when I
challenging.
was in college and I was an industrial engineer, they used to call us imaginary engineers because they said we had the easiest engineering major. I fully disagree. But you know, it was an IE degree. It's like, oh, those are the imaginary engineers. That was a while ago.
Hey, you could go into Imagineering, which has a whole different perspective now, right? Down at Disney World, I think if I were starting over again,
perspective, that's right.
that's where I would go.
But I think I would agree with Mr. Andrews and Ms. Smootz that you know, really whatever engineering you go into, it can be a bumpy ride, but it's worth it if that's what you like. You know, there is that saying that I forget exactly the words, but essentially, if it's worth doing, you know, it's worth spending some effort on. You know, so engineering, regardless of which type you'll take, you'll definitely expend some effort. But if that's what you want to do, I would say, you know, don't let difficulty in and of itself shy you away from doing it.
So, Ms. Smootz, we've been on for almost 50 minutes. I don't know if there was any other items you had intended for us to cover.
No, you all have a phenomenal crowd. To all of the CFS students who jumped in to help, thank you so much. Thank you, Mr. Labrador, Mr. Andrews, Ms. Mulcahy. Really appreciate your support of this evening. And no, I think that we've answered the questions. If there are any more questions from the students, you're welcome to reach out to the admission department, and we'll either answer your questions or put you in touch with someone who can. Tomorrow night is the same presentation from the art department. And so if you're interested in band, drawing, photography, music tech, choir, make sure you log on tomorrow. We'll send out a reminder so you have those links. And other than that, I'd say thank you to everyone. We appreciate your time this evening and have a wonderful evening. Thank you. Bye-bye.
All right.
Thank you.